Hello, welcome to Chapter 7, Section 4, where we're going to talk about properties of logarithms. In these videos that I'm going to make, I'm just going to kind of get straight to the point and tell you how we use these properties. In class, hopefully, we'll have a little bit more of a discussion about why do these properties work. In general, though, I have a hard time, doing what I just said I was going to do. In general, the properties of logarithms are extensions of the properties of exponents. Remember that the logarithm is the exponent. So if I have the same base to a power multiplied to the same base to a different power, I would add the exponents. So I'm working backwards with that. I'm going to take it from where I'm adding the exponents, and that goes back to where I'm going to multiply okay, so anyway, I'm getting ahead of myself. I'm doing what I said I wasn't going to do. So I'm going to show you how this works. Here's the properties. I stole this from the textbook. The first property is called the product property. The product property works if I have the same base. That's important. These properties these first couple of properties, you have to use the same base. So what this means, and this goes either way, and this is the example, but go either way. If I have a logarithm of logarithm to a base of a number, and I'm adding the logarithm same base of another number, and I drew in the parentheses, you know how I feel about that. That's the same as if I take the logarithm, again, keeping the same base, and I multiply that number times that number. Now, again, this is really using the idea that when I multiply powers, I'm going to add the exponent. So for example, like for this problem, this comes from the fact that I have 10, well, okay. If they're using log base 3, so I guess this isn't going to work, so ignore that one, okay? But if I was doing the common log of 10 times 100, I don't know why they put the 3 in there. Anyway, then I know that this would be 10 to the first power times 10 to the second power. And what do I do inside that? What do I do with those exponents? I'm going to add those exponents. All right? So that's why if I had log of 10 plus log of 100, that would be 1 plus 2. Again, I'm adding the exponents just like I'd be adding the exponents if I was taking care of the of the power. Okay, so that's kind of where it comes from. Essentially, all that we need to do, if you look at the examples, we're going to be given addition problems, and all I have to do is multiply what's inside the parentheses, and then if I can, simplify it. So for the first one, I have the same base. This is base 4, so this is going to be log base 4 with the subscript, and inside I'm going to multiply 2 times 32. And of course, simplify. Log base 4, 2 times 32 is 64. Okay, so that's the first part. I expressed it as a single logarithm instead of two logarithms being added together. So that's the first part. The second part, simplify if I can. So I'm going to think 4 to what power equals 64? Because my base is 4, that means that the base of the corresponding inverse exponential function would be 4. And since the logarithm is the exponent, I'm asking what's the exponent when I do 4 to that power equals 64. And of course, 4 to the third power equals 64. So again, there's two things. Express it as a single logarithm, that's this part, and then simplify, that's that part. Let's do this one. So I'm going to express this as a single logarithm. I write log base 5 of whatever 625 times 25 is. And I might need to use my calculator for that. That one's kind of, well, I don't know, do it by hand, I don't care. But when I do multiply log base 5, I get 15,625. All right, so that's the first part. I expressed it as a single logarithm by multiplying the 625 times the 25. Now I need to figure out what the exponent is. So I'm thinking 5 to what power equals 15,625. Okay, maybe that's on my powers of 5 that I have. And my powers of 5 were 1, 5, 25, 125, 3, hang on. I gotta double check. Yeah, 625, and then 3,125, and then do that one more time, I get 15,625. Sorry, started to smudge that there. So this would be first power, second power, third power, fourth power, fifth, sixth, seventh power. So I think that that's 5 to the 7th power. And of course, you can grab one of these, that's fine. Let's check it to see if it works. 5 to the 7th power. Whoa, sorry, I went too far. Oh, you know why? Because I counted 0, 1, 2, 3, 4, 5, 6. Whoopsie. It's actually 6. I knew that. I don't know why I messed that up. Good thing I checked. 5 to the 6th power. That's what I was looking for. For the last one, write it as a single logarithm. I'm going to write log base 1/3. Don't panic about that. And I'm going to multiply 27 times 1 over 9. Now, if I simplify this is the same as 27 divided by 9. So that becomes log base 1/3 of 3. And this one, to be honest, even with the fraction, this one's actually a little bit easier than that one. 1/3 to what power equals 3? Well, these are reciprocals of each other. So that means that my exponent, I didn't give myself enough room, is -1. 1/3 to the -1 power equals 3. And again, if you don't believe me, check it. 1 divided by 3 to the -1 power. That's why you have to use that negative key right there. And yeah, that does equal 3. So this gives me 3. Okay. Just real quick before I sign off for this. This product property of logarithms is probably, I saw it listed somewhere. These are the things that people send me on Facebook, or like the Facebook algorithm knows I'm a math teacher, so it finds me. And this was in like the 25 most important equations that humans have ever created. Believe it or not. The Pythagorean theorem is in there. So this right here, a product property of logarithms, this is how complex calculations were performed before we had the electronic technology. And it's one of the things that I missed out. I know you guys think I'm old, but it's one of the things that I missed out. I don't even have one, but this allowed people to use what's called the slide rule. So if you think about it, before people were walking around with like these type of calculators, or even, things that are more simplified than that, a lot of the calculations were done with these things called slide rules. I know. And I wish I had one so I could show you. I wish I knew how they worked, actually, to be honest. So this equation with engineers that were able to use slide rules was how we were able to get human beings to the moon. It's that important. Okay? So anyway, yeah, I know I shouldn't really be talking about like the history of things in these videos when you're trying to watch stuff, okay? So I'll be mindful of that, and maybe I'll say something about it in class. Bye.